All right, so in this lecture, we are going to look at the third practical. Now, there's no past question on the third practical. These questions here are just based on the important details that I know may likely want to come out under this one. Is that okay? Now, the question says the synthesis of benzoin from benzaldehyde is an example of a carbon-carbon bond formation. This is an important question also. They may ask you, what kind of reaction is the synthesis of benzoin from benzaldehyde? It is a reaction. It's an example of what? A carbon-carbon bond formation. Or you can say that it is a condensation reaction. All right, any one of these you say is actually very, very correct. Say provide a suitable catalyst for the for this kind of reaction. Now, how do we provide a suitable catalyst? I have said earlier before, this is number one question. Question one. Now, I've said earlier before that the catalysts that they usually use are the nitrides, right? Now, in this case, they use, it's either you use sodium nitride, or some cases you can even go as far as using potassium nitride, depending on any of the nitride you can use. Now, I've said earlier that these nitride are what? They are nucleophile. And then what is their function there? They make the benzaldehyde protons to be more acidic. Make benzaldehyde protons to be more acidic. Is that okay? Now, the next question here. Write the reaction equation. Now, you may be given the reaction equation, you may be asked to write it. Now, the reaction involves benzaldehyde, sodium nitride, or let's say potassium nitride. Any one of them can actually go. Are you getting it now? So let's use benzaldehyde. What is the structure of benzaldehyde? This here is the structure of benzaldehyde. Is that okay? This here is the structure of benzaldehyde. Now, the question now is, what is the equation of reaction? So you have benzaldehyde. How many molecules of benzaldehyde that is actually reacting? You have 2 molecules of benzaldehyde. It's more like a self-condensation reaction, plus either potassium cyanide or sodium cyanide. All right, this is going to give you, now this reaction is very simple. Do you know that this benzaldehyde can also be written, of course, how many carbons do you see here? This compound here first, the benzene ring, 6 carbons, so it's C6H. How many hydrogen? Each of these have hydrogen. This one has been substituted, so we have 1 2 3 4 5 hydrogen. C6H5, and then you have CH, which is this CH, and then O. We need 2 molecules of this plus sodium cyanide. It's a kind of condensation reaction in such a way that in one instance, this group here will be converted to alcohol. Is that okay? So you are going to have 2 of this benzene ring. What do I mean by that? You are going to have something like this. This is a benzene ring. All right. Then you are going to have this group here converted to alcohol. This group here. Now, if it is converted to alcohol, then you are going to, this hydrogen comes down, then attach another one of these benzaldehyde. So if you attach another benzaldehyde, that will be what? C, double bond O. Are you getting it? And then you are going to have this other benzene ring. So this is the structure that will be formed. This is the structure of benzoin. Now, this may be another question. They may say, draw the structure of the product form, which is benzoin. This is benzaldehyde. This is the catalyst. Why this is what? Benzoin. All right. Now, if you want to put benzoin in using this format I was using under here, okay, let me use this format I'm using under here. This will give us, because first of all we have C6H5. Is that okay? Then we have this carbon. All right, this carbon is bonded to what? Hydrogen. So I can have it as CH, and under here, either under or on top, but because there's no space on top, I'll put it under here. You have the OH. Are you getting it? And then of course you have your this carbon here, which is this one, then double bond up, then of course this group here is what? C 6 H5. So this is another way to write the equation of reaction. Is that okay? So how many moles of benzaldehyde do you need for this reaction? These are potential questions. You need 2 moles of benzaldehyde. So when you are doing your calculation, you say 2 mole of benzaldehyde give rise to what? 2 mole of this and 1 mole of this. Is that okay? This is 1 mole. Now if you want to write the equation for this, this will be C6. You can put it as the form of it, C6 CHOH, then CO C6H5. This will be the molecular formula. Is that okay? So that is that for that question. Now let's see the next question. We've written the reaction equation. So we are done with this. We are done with this. What is the fate of the product formed? Now, what product is formed? Benzoin. What is the fate of benzoin? That is another question. Fate of benzoin. Now, in the manual, it was stated that benzoin is an important intermediate for the synthesis of benzyl. By what method? Oxidation method, which we are going to come to. Then you were also told that this benzyl can, 2 things can happen to this benzyl, right? One, it can be rearranged. So when rearrangement takes place, it will give benzylic acid. Then when condensation with urea, you can react this benzene condensation with urea. Are you getting it? What kind of reaction? Condensation with urea. All right, is going to give hydatoin derivative like phenytoin. Is that okay? Hydatoin derivative. Example of that hydatoin derivative is what? Phenytoin, which is used as an anticonvulsant. All right, so this is another use of what? Benzoin that is formed. The benzoin that is formed is used for the synthesis of benzylic acid. It's also used for the synthesis of hydatoin derivative when it condenses with what? With urea. Is that okay? So that is that for that question. So that is question number 3. So we are done with number 3. This is number 3. Now let's see the next question. Discuss the method for the reaction. Now, what is the method for this reaction? You may not get the actual amount that you have to weigh. Of course, you know the reaction involves benzaldehyde. Now, benzaldehyde is an aldehyde. Of course, it's in liquid form. So you are now going to say weigh or measure, in this case now, weigh 20 grams or weigh an amount. You may not state the amount of benzaldehyde. That is one of the steps. After weighing this amount of benzaldehyde into a 250 ml round bottom flask, put this, transfer it into a 250 ml round bottom flask. All right, this one here. Then you actually the round bottom flask is already containing the sodium cyanide. The round bottom flask is already containing the sodium cyanide, an amount of it. In this case, they say 20 ml of 10%. All right, they say weigh 20 gram here. You may decide to put the gram in your head. For me, I will just say an amount of benzaldehyde was weighed and transferred into a round bottom flask containing sodium cyanide. Then after this, the next step now is to reflux by boiling in a reflux equipment. Reflux with boiling on water bath. To reflux means ensure that they mix together. Mix them by boiling. In what? Water bath. Is that okay? Now, after boiling, the next step now is cool it. You cool in ice bath. Then after cooling in ice bath, then the solid will actually, it will crystallize. So after cooling in ice bath, the process is crystallization that will occur. To crystallization, so this is going to form solid crystals. Now you wash these solid crystals with cold water. Wash with cold water. Is that okay? Plus filter it. First of all filter the solid from the solution first. So you first of all filter, then wash with cold water. Are you getting it? Then after washing with cold water, you filter again. Then you dry it, and after drying, you can then recrystallize. So we can come from here. You can then recrystallize with, we use methanol, but here they say methylated spirit. Methanol. Are you getting it? To remove impurity, then weigh and then calculate the melting point. They may ask you, how do you characterize? You do melting point analysis, UV, all these things I listed earlier for characterization. Is that okay? Then write the mechanism of reaction. How do you write the mechanism of reaction? Now, they may not really ask you to write the mechanism of reaction. Is that okay? But nothing is impossible. Nobody might actually ask you to write the mechanism of reaction. But like I said, nothing is impossible for PharmChem to do. So if they say you should write the mechanism of reaction, how do you write the mechanism of reaction? The reaction contains benzamide. This is the structure of benzamide. Now, you are using sodium cyanide. There's a bond here. This cyanide here is a good nucleophile. It can attack this one. This one will come up. Are you getting it? Now, it is not the full sodium that is actually attacked. Sodium cyanide. It's only the cyanide part of it. So this is going to form something like this. All right. O negative. And here will be, the cyanide will be under here. And then here will be your hydrogen. Are you getting it? Then at this point in time, you pass it through water, H2O. All right. Now H2O, you can write it as something like this: O H H. You see it's written as H2O. Because of this negative charge here, you can come abstract a proton from this, and then this one pack to form what? This is now going to form OH minus. So what are you going to form here? You're going to form something like this. Like I told you, if you cannot carry it, just leave it. They may not ask this. All right. And then you have your Cn negative. After this now, the next step is OH negative coming in again. Is that okay? OH negative coming in to withdraw a proton from this. So you are going to have OH negative. Now what would that OH negative do? It will come here, remove this proton from here. If we remove this proton from here, what are we now going to form? We are going to form something like this. All right. And here will be C, O negative, H, and Cn. Is that okay? Now, at this point in time, now listen, it's not going to remove this proton because this proton is for OH, so it's not easily removed. The proton is going to remove is this one from here. All right, is this one from here. So we are going to have something like this with, here will be OH. Sorry about that. Here will be OH. You remove proton from here. When you remove proton from here, this negative charge will still be there because it's gonna, sorry about that, the negative charge will still be there because it's gonna pack in here. I'm supposed to use red. It's gonna pack in here. So what are you expected to have now in this case? There will be a negative charge here, so here will be a negative charge. Is that okay? Now this negative charge is now what is going to react with another molecule of benzaldehyde. Is that okay? So you are going to react this with another molecule of benzaldehyde. So if this is benzaldehyde, let me just put it this way. C double bond O H. And then this O thing, we can decide to turn it in such a way that it will be O negative OH. Here will be what? Negative. Here will be Cn. And then, of course, we have this group. It's still the same thing, right? Exactly. So this group here, we come, take this one away. This one will come up. Are you getting it? So that you are now going to form a joint compound. So what is the compound you are going to form? What is it going to look like? It's going to look something like this. Here will be CO negative. Are you getting it? Here will be your hydrogen, which is this hydrogen. Then the compound is going to attach here. So here will be C. Here will be Cn. Here will be OH. And then you are going to have something like this. It's looking like our product. The product we want. But the product we want, we don't want Cn out of here. We don't want Cn here. So because we don't want Cn, we are going to react this with OH negative. This OH negative is going to take a proton from here. When it takes a proton from here, here will now become negatively charged. So what will that give to us? All right, you don't need all these ones. It's not very long. In my eyes, it was looking so short. So this will give us this, and then this will be O negative. Are you getting it? Yeah. Okay, we've not come to this extent. I think we are good like this for now. We will not do that at this stage. What we are going to do at this stage, because if you follow that part, it's not going to give you the answer. What we are going to do at this stage is to react it with one water molecule. All right. So if you put water here, just forget about it. It's not going to come out. It's becoming too long. All right. So that is that. Now, what are some of the uses of benzoin? We said benzoin, they are used, of course, you know the fates I told you before. They are used for, they are intermediate for the preparation of benzene, which can be condensed. They are also used for the preparation of what? Where benzene, the benzene formed from benzoin condenses with urea, is going to form hydantoin derivative like phenytoin for anticonvulsants, right? Those are uses. Then other uses is that in small quantity they are used as flavoring agents in small quantity. Then benzoin also is used for skin ulcer. Benzoin also is used for what? For skin ulcer. Now it is also a sap that is actually gotten from the trunk of trees that belongs to the what? The styrene family. So that is everything you need to know about that. Now, last question. Calculate the theoretical yield if 20 grams of benzaldehyde was used. Now, coming back to this, 20 grams of benzaldehyde was used. You know how to solve something like this by now. According to what I said, we first of all calculate the mass of benzaldehyde. But you know, in this case now, that 2 moles of benzaldehyde was actually used. Is that okay? So, molar mass of benzaldehyde will be what? To the benzaldehyde is C6H5CHO. This is benzaldehyde. 1 mole of benzaldehyde gave rise to 2 moles of benzaldehyde gave rise to 1 mole of C6H5CH OH COC6H5. Are you getting it? Now let's calculate the mole of benzaldehyde. This is 2 times carbon is how many? 12 times 6 plus hydrogen is how many? 1 times 5 plus carbon here is how many? 12 plus hydrogen here is 1 plus oxygen here is what? 16. So what do you think is the molar mass of benzaldehyde? How do we calculate the molar mass of benzaldehyde? The molar mass of benzaldehyde will be calculator open. So we have normally 12 times 6 plus 5, which is 1 times 5, plus 12 plus 1 plus 16, which is 106. But because you have 2 moles there, to be 2 times 106, 2 times 106 gram. So that will give us times 2, which is 212. Are you getting it? Which is 212. So we have 212 gram of C6H5CHO. All right, and then you have 1 mole of this. Now, what is the molar mass of everything you have here? Carbon is 12 times 6. Hydrogen is 1 times 5 is 5. Plus this carbon here is 12. Plus hydrogen here is 1. Plus oxygen here is 16 plus 1. Then plus carbon is 12. Oxygen is 16 plus 12 times 6 plus 5. What do you think that is going to give to us? So we have 12 times 6 plus 5 plus 13 plus 17 plus 12 plus 16 plus 12 times 6 plus 5. Okay, that one gave us 212. Are you sure? Yeah, it gave us 212. Are you sure this is correct? Yeah, it's supposed to give us 212 because we actually used 2 mole of this to form it. So nothing was actually lost at the end of the day. So it gave us 212. The reason why I'm asking is because here, I got 211. Let me just check. Molecular mass of benzoin. Two one two. So the molecular mass is 212 as opposed to 211 we have here. So this is going to give us 212 gram of benzoin. This is supposed to be the right thing we will do. Well, everybody copied, so we all copied nonsense. All right. So 212 gram of this is equal to 212 gram of benzoin. Therefore, now how many gram of benzaldehyde was given to you from the question? Look at it, 20 gram of benzaldehyde. So it will be 20 gram, normal calculation of C6H5CHO would be equals to what? X. Cross multiply. Of course, you know this will cancel out this. So you are left with 212x, alright, would be equal to 20 gram times 212. So divide both sides by 212. Divide both sides by 212. This cancel this. X would be equal to, when you divide this by this, it will still give you 20 gram. So that will actually give us 20 gram of benzoin that is supposed to be formed. So the theoretical yield is 20 gram. So in a situation where they gave you the actual yield, let's say actual yield is 18 and they say calculate percentage purity, it will now be what? 18 divided by 20 times 100%. Is that okay? That was what we were supposed to do here, but I guess we all did very beautiful thing. So all right, so that is that. We'll see in the next one. I believe that is every other thing. Then if they ask you the I arrow, those things, you just benzoin, it has OH functional group, so you are going to see I arrow at 3600 for OH. It has the C double bond O functional group, you are going to see it at 1600 to 1700. Then the benzene ring at around 1600 also. I think those are the only things that are there. The mass spec and the rest, I don't think they are going to ask all that. So that is everything for this particular practical. We'll see in the next one.